Okay, welcome to another Ginger Mathematician video. So in this video, I'm going to go through a sample 11 plus maths exam walkthrough for those 11 plus exams in September. So this is good practice. This comes from the website you'll see in the description as well. So this is a multiple choice test. It's 50 minutes to do the test and 50 marks. So it keeps everything very straightforward. You get 1 minute per question. And I may go through it roughly the same pace as that, but if I need to take time, I certainly will. Right, let's get started. So our very first 5 questions. Which of the following is the most likely weight, so I'm underlining the key words here, of a bag of flour? So out of the 5 options, the first ones I can remove is millimeters, because that's a length, that's not weight. Litres is capacity, like fluid, milk or water, things like that. And then I have my 3 possibilities. Well, 2 grams is really, really small, yeah, for a bag of flour. So I don't think this is this either. So now I've got 2 choices here, either 2,000 kilos or 2 kilos. And well, 2,000 kilos is huge. Yeah, imagine how much 2,000 kilos is. That doesn't seem very likely for flour. I'm sure many of you out there bake. So from the process of elimination here, it must be E. So it must be 2 kilograms. Again, for each of these, I will go through the answer as well. Look at the grid on the right, question 2. Molly starts at the star, so we start here. She moves 2 squares southwest. Now, we're given the compass, that's very helpful. So we need to move in this direction. So I'm going to copy that direction across. 2 squares. So 1, 2. Then she moves 2 squares north from there. So we go 1, 2. And then finally we go 1 square east. And then we have to decide what shape is that. Well, if I draw this shape out, we need to count how many sides there are. So I'm looking at this shape here. And we have 1, 2, 3, 4. And 5. And a 5-sided shape is called a pentagon. Okay, you're going to need to remember that to succeed in the 11 plus exams. You need to know what a hexagon is, what a decagon is, and so on. So our answer is going to be C. Question 3, we have a bus timetable on the right. Jemima, great name, lives on Hart Street. She wants to arrive at Maple Lane, so we want to arrive here before 10:15. So we only have 2 choices here. You either have to go for this time or for this time. So we need to consider which one gets us there before 10:15. Well, it has to be this one, okay, because this is too late. That's almost 45 minutes too late, 44 minutes for those paying attention. And then what time should she catch the bus from Hart Street? So we go back to the time we would need to go at Hart Street, and that will be 9:10, which I will write in the gap like so. All good. Question 4. How many thirds are there in 9? It's an interesting style of question. How many in? So as soon as I see that phrase together, I know it's a dividing question. Again, looking for the patterns of the question to help you know exactly what to do. And we need to know how many thirds. So we generally write thirds as this, 1/3, or that fraction practice from year 5 and year 6. And we need to know how many fit into 9. So the calculation they're asking us to do is 9 divided by 1/3. Now this might be slightly different to the way your teachers have taught you how to do this. But again, this is why I do these videos. I like to try and give you other methods. Whenever we divide by a fraction, we need to think of the phrase keep it, switch it, flip it. And this is a phrase I'd certainly teach my year 7s when they go into secondary school. So what do I mean by this? Let's break it down. So keep it, we keep the first number. We switch, we change the divide to a times. And then we flip the last fraction. So we flip it over. So we get 3/1. That's what I mean by keep it, switch it, flip it. This is something you'll practice in year 7 and year 8 as well. And at this point, well, 3/1 That's just 3. How many 1s go into 3? Well, 3. And then we just have to do 9 times 3, which is equal to 27. They're your times tables. So this one is going to be D. As you see, I took a bit longer than 1 minute here, but that's absolutely fine. It's worth taking the time. And now we've got question 5. Look at the shape on the right. Which angle is obtuse? Another word that we need to know. So what the word obtuse means, it's an angle between 90 degrees and 180 degrees. Okay, so if I do this visually, it's an angle that's between 90 degrees, so this is a 90-degree angle. It's between that and 180 degrees, which is just angle on a straight line. So it's an angle that's between these two angles. So let's go through and see if we can discount some. Well, this is too small. This is smaller than this. So we can cross out A. This is also too small. This is also too small. And so we have a choice between B and C. Well, notice C goes beyond a straight line. It goes beyond this one. So it can't be this. So the only angle that makes sense is this angle here, angle B, which we're going to circle. Perfect. And if I've gone through anything particularly here too quickly, that's absolutely fine. This is a good chance to pause the video, look at the explanation from the CGP as well. If you're liking this content and you like the new approach of taking 11 plus exams, then please do like and subscribe. It goes a long way to supporting the channel and telling me you like this, you don't like this, and so on. So thank you for liking and subscribing. Let's move on. Question 6. So we have a class of Year 6 children. We're asked whether they like tigers, giraffes, or lions. I'm sure many liked all of them. And we need to work out how many children from the diagram said they liked both tigers and giraffes, but not lions. So let's highlight first of all the first part of this. Which section likes both tigers and giraffes? Well, that's going to be this section here, the bit in between tigers and giraffes. However, they do not like lions. So they can't be right in the middle, because the middle number here, 3, that represents tigers, lions, and giraffes. So we actually need to take the 5, because these people here do not like lions. It's not in the lion circle. So our answer here is going to be C. It's going to be 5. Perfect. On to the next one. Which of these numbers is the smallest? Well, if we, again, do some elimination here, well, it has to be a number that starts 0 point something, because the 0 represents our units. So it can't be this, and it can't be this, and it can't be this, because it has a 7 at the start. So now we need to decide which one is bigger. My little trick for this is to make sure I put a 0 as a placeholder. So I can compare directly 0.70 and 0.77. And I think we can see clearly here that this 77 is bigger than 70. So we can just choose A as our answer. Good, good. And length of each side of this shape is 4 centimeters. What is the perimeter of the shape? Again, that's a really important word to know, not just in Year 6, but also Year 7 and beyond. The word perimeter means the distance around the outside of the shape. Around the outside. So let's do that for this shape here. We know each is 4, so we've got 4, this is 4, this is 4, this is 4, this is 4. Probably sound like a broken record. This is 4, this is 4, and guess what? This is also 4. And then we add up how many 4s that we have. So we've got 4, 8, 12, 16, 20, 24, 28, 30, 32. Which I'm sure some of you worked out you could also do 8 times 4 here as well. That would speed up the answer. So let's check that again. 4, 8, 12, 16, 20, 24, 28, 32, 36. Okay, hopefully you spotted the deliberate mistake there. So actually the answer is 36. So this point here, so it should be 9 times 4 of course. The point I'm making in this question is always check your working. Notice I made a deliberate mistake here to make sure you're paying attention and make sure you check your answers. I would also check a third time now. 4, 8, 12, 16, 20, 24, 28, 32, 36. So make sure you check your working, okay? Anybody can make a mistake, that's absolutely fine. But as long as you're willing to check these things as you go along, that's fine. Good. On to question 9. So 47,983 people went to a football match. What's this number rounded to the nearest 1,000? I'm going to put an underline here. So my first thing is to write this number down. So 47,900, 9 in the hundreds column, and 83. So you need to practice that skill of going from words to a number. That's really important. And now we need to decide how to round this to the nearest 1,000. Okay, so the first thing we do is we're going to work out where the 1,000 column is. This is units, this is tens, this is hundreds. Aha, we have 1,000 here. Then after that, I'm going to do this with a different pen. We draw a line after the thousands. We look at this number 9. We ask ourselves the question, is this 5 or above? It definitely is. 9 is definitely more than 5. So we're going to round this number 1 up. So what's 1 more than 7? Well, that's going to be 8. But then don't forget to put our placeholders in for the hundreds, tens, and units. So we put 0, 0, 0, giving us the correct answer here. D of 48,000. All good. Right, question 10. There are 25 CDs in a box. And a shop orders 14 boxes. How many CDs did the shop order? Okay, how many? 25 in a box. And in the box, there are 14 of them. So all these key words here are indicating to me that we need to multiply. Notice they've told us how many in a box and then how many boxes we have. When you have this chain afterwards, that gives a hint that we need to multiply. So we need to do 25 times 14. Now, you could do this traditionally. You could use this method here and work your way through. That's absolutely fine. You can use that very useful Year 5, Year 6 skill of partitioning. So what I'm going to do here is I'm going to separate out 14 into 10 and 4. So this is what we call partitioning. I'm sure you're familiar with this from primary school. So I'm going to do 25 times 10, just think about the tens, and then I'm going to do 25 times 4, just think about the units. So 25 times 10, well, that's going to be 250. Remember, all the digits shift along to the left. And then 25 times 4, well, 4 lots 25, 25, 50, 75, 100. So we can pop that in. So if we add those numbers together, I'm sure you can do that mentally without having to do this method here, but you'll get the answer of 350 CDs. That's a lot of CDs. I don't have that many, I can assure you. They've all gone. Right, I'll just show you the answers quickly. So you can go through these again at your leisure and read the explanations here as well. Perfect. Okay, so on to question 10. Oh, that was question 10. We've done that already. Don't have to worry about question 10. I'll put a cross because we've done this. On to question 11. So, class of children were asked what their favourite sandwich filling is. The results are shown by a bar chart. 25% of children said they liked ham. What percentage chose tuna? Okay, that's an interesting question. So, let's underline the key information. 25% of the children said they liked ham. Okay, so let's work out how many liked ham. So we've got 8 liked ham. I'm going to write down the information very clearly. We're also told that 25% liked ham. Okay, so that's my information there about the ham. Now let's focus now on the tuna. So we're told that 16 like tuna. I like tuna as well. And now we need to think what percentage chose tuna. Well, what do we do to 8 to get to 16? Well, we multiply by 2, that's doubled. So we need to do the same with the percentage. It's what I like to call linear. So if we times that by 2 to keep in the same proportion, well, 25% times 2, that's going to be 50%. So 50% liked tuna. So let's pop that 50% like so. Excellent. So question 12, what fraction of this shape is shaded? Notice each section is the same. You should always check that before you do anything. So let's see how many sections in total. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So you've got 12 sections. Out of those sections, how many are shaded? 1, 2, 3, 4, 5, 6. 6 out of 12. And if I simplify that fraction, well, how many 6's go into 6? Well, 1. How many 6's go into 12? That's going to be 2. And then we get our answer of a half. So I'm going to circle that one. All good. Which of the following statements is correct? So, quick reminder of these signs. This sign here, that means less than. And this sign here means greater than. Okay, so when you're reading that, that's how I read it. So for example, if I take B, 52 is greater than 5,200. Now I read that out, that makes no sense whatsoever. So we just cross that one out. If I read this one out, 520 is less than 52. That makes no sense. So we're going to cross that out. Okay, so we've got 3 choices. Well, let's do this one. This seems the easiest one to work out. 52 times 10, well, that's 520. Oh, that looks like one we already did. 520 is definitely not smaller than 52, so we can cross that one out. So we're left with these 2. Let's do this one here. So let's do this down here. Well, 520 divided by 100. Remember the method you should do when dividing by 100, and put the decimal points in, is remember everything shifts along. Now, some teachers will teach you this method here. So they'll teach you, this goes 2 to the left. That's not strictly true. What's actually happening is all digits shift. But you'll get to the same answer, which will be equal to 5.2. What I always think here, okay, you shift the digits twice along. What makes sense? Well, dividing by 100, it's going to make the number smaller. So 5.2 makes a lot of sense. And then let's have a look. 52 is greater than 5.2. That sounds correct to me. So we're going to circle C. Perfect. Odd question 14. A factory makes 4,596 nails in a week. 2,914 of the nails are sold. How many nails are left over? As soon as you get this kind of leftover phrase, again, how many? So we're picking out the key words here. Are sold, so i.e. they disappear. Yeah, removed. Okay, this all indicates we're going to subtract. So again, using those keywords to tell us what's going on. So essentially, this is asking us for that standard subtraction you've practiced for many, many years at this point. So I'll go through this pretty quickly. 6 minus 4 is 2. 9 minus 1 is 8. 5 minus 9 we can't do. So we borrow 1 from the 4 to make 3. We take the borrowed 1, put it next to the 5. 15 minus 9 is equal to 6. 3 minus 2 is 1. And we get our answer of 1,682. Again, you should check this in the exam as well. So go through the same process again. Imagine you've seen it for the first time. This is the way that you are going to improve. All right, let's show you the answers very quickly so you can check what you've done at your leisure. So give yourself a moment and then we are going to move on. Okay, question 15. So Ibrahim is trying to work out the volume, keyword, of a swimming pool. What units should he measure the volume in? So first thing, volume always has units with a cubed. Okay, so it always has this little 3. So we can cross out anything without a little 3. So This one and this one will not be acceptable. And then we need to think, the volume of a swimming pool. Well, millimeters are really, really, really tiny, so it makes no sense for a big swimming pool. And cubic centimeters, well, you usually use that in science experiments, don't you, for those, little test tubes, etc. So that also seems far too small. So by elimination, it must be cubic meters, which is our answer. Sunita has 75 pens and she ties them into bundles of 8. How many pens does she have left over? So again, we've got that left over, so something being removed. So we're thinking either subtraction or division at this point. We've got this word bundles, so collections of 8. So with this word here, this is then indicating I need to divide. Got left over, so subtraction, division, but we're putting it into groups of 8. As soon as you start talking about groups of things, then you're going to be thinking division. So how many 8s fit into 75? We have a lovely method for this. We have what's called a bus stop division, like so. Now there's different ways you can approach this kind of question. I'm going to stick the British method of short division. So let's go 8 into 7 goes 0. Okay, so carry the 7 over. Then we do 8 into 75. So we think about our times tables. You should know your times tables more or less off by heart. I'm going to choose a number that's close. So 8 times 8 is 64. And then we've got 9 times 8 is equal to 72. That's pretty close. 10 times 8 is equal to 80. Oh, that's far too much. So 8 go into 75. Well, 9 times, because 9 times 8 is 72. And then we need to work out the remainder. So what's the difference between 75 and 72? Well, again, we can always use this method if you get stuck, but hopefully you agree it's equal to 3. So we get 9 remainder 3. So essentially this remainder literally tells us how many left over, how many remain. It's essentially the same idea. So the answer here is just the 3. We take our remainder. Good. Next question seems really tricky on the surface. 21.7 times 9.4. Let's use a little bit of mathematical trickery here. First of all, we know it ends with a 7 and a 4, these two numbers. So if we do 7 times 4, in your timetables, it's equal to 28. So we know it should end in an 8. Whatever number we get needs to end in an 8. So we can cross out many of these answers, which is kind of cool. So we know it can't be any of these. So we've got a decision between A and E. A little bit of estimation goes a long way here. So if we round these, so 21.7, kind of close to 22. 9.4, kind of close to 10. Now I'm not rounding, strictly speaking, to 9. I could do that. I'm doing something very close. Don't have to round precisely. But this gives me the idea that a number should be around 220. And so which number is far closer to 220? Well, it's going to be D. This number is far closer than 287. Notice I did not do perfect rounding, but it gave me a good idea of what to select. So question 18, which 3 numbers can go in the shaded box of the table? So we need factors of 70. Let me write this down. Factors of 70 and prime numbers. So remember, a prime number is a number that only has 2 factors, 1 and itself. So can we remove numbers that are not prime? Well, 1 actually is not prime, which people often forget, so it can't be this one. 14 is not prime because 7 times 2 is 14, so that can't work. 10 is also not prime because 5 times 2 is 10. So it has to be either B or D. And now we look at the other part of it. So I've checked the prime part. Now let's look at factors of 70. Well, 11 does not go into 70. So this one can't be true. Therefore, it has to be B. It has to be the 2, 5, and 7. So we circle B. Next one. So what is 3/5 of 60? I have a very clear method for doing this. And that is divide by the bottom. I'm sure my Year 7, Year 8 students can chant this, times by the top. As soon as you see fraction of next to each other, you need to think this phrase. Just think this phrase when you see of, fraction, or times and fraction next to each other. So we do this in 2 easy steps. We take the big number, 60, we divide it by the bottom, which is 5. So 60 divided by 5, you could use this method up here to work this out. Or you know your times tables. Working backwards, 12 times 5 is 60. So 60 divided by 5 is 12. And then we take that answer and times it by the top, which is the 3. So if we do 12 times 3, again, if you know your times tables, that helps. But you can count in 12s as well. So 12 plus 12 is 24. 24 plus 12 is equal to 36, which is going to be RE. Perfect. Again, feel free to check your answers, check the explanations, and make sure that you're happy with how this works. Again, may not follow the exact method that you see in front of you, but I try and give you a few little tips and tricks. Being a secondary school teacher, I kind of know what's coming for you, so I do try and fit in some secondary methods at the same time. On we go, we've got 2 more slides, and then we'll stop there for today. So what number is the arrow pointing at? So we've got a scale here. So let's think about our scale first of all, and what each thing stands for. So let's see how much we've got difference in between. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it looks like it goes up in 0.01s. Yeah, this is worth checking. So in the exam, I go, okay, this is 4.51, 4.52, 4.53, 4.54, 4.55. So I check this is the case. I'm not just believing that it's going to work nicely. 4.56, 4.57, 4.58, 4.59, 4.6. Okay, so what I said there is correct. It's going up in 0.01s. And then we just count. So 4.5, 4.51, 4.52, 4.53. And so we have part C. Now Marvin, great name, made a pie chart to show the eye colours of the children in his class. Amber, is that really an eye colour? Who knows? What is the modal eye colour? That's kind of a strange word, isn't it? So as soon as you see mode or modal, comes from the French à la mode, so fashionable, yeah? So in real English it means it's the most common number. That's all that modal means, the most common number, the most fashionable number. So the largest part of the pie. So I think we can see pretty clearly here that the largest part of our pie chart is going to be blue. It's the biggest section. If someone was asking me, have some pizza, I would choose the blue part every single time. So therefore our answer is going to be B. Okay, and question 22, that's a little bit of a tricky one here. So which of these calculations give us the largest amount? So again, we always have to remember BIDMAS, yeah, that's really important. So we need to think about how that's going to work. So BIDMAS says that we always do the multiplication first. Notice these are all structured in the same way. Yeah, it's always multiplication here first, then we've got some adding and subtracting. So because multiplying gives you a bigger number than adding, yeah, say I did 7 plus 8, that's equal to 15. Whereas 7 times 8, wow, that's huge, yeah, that's 56 in comparison. So I want my biggest numbers to be at the start to give me the very biggest number. So notice I'm doing no calculation here, but I'm using some reasoning. So my answer has to be A here, because my biggest numbers, 21 and 20, are at the start. Now, of course, you can go and check this and check every calculation, but you've only got 1 minute to do this question. So you need to realize that you want your biggest numbers, I'm going to write this down, biggest numbers to be multiplied to give you the biggest answer. Again, don't be tempted to work all these things out separately. You'll be there too long, and you don't have long. You only have 1 mark here. So, and if you were tempted to do that, skip this question, go on to the next question. Right, check your answers, 20, 21, 22. Make sure you're happy with the explanations. We've only got a few more before I'll finish this particular video. Okay, so Mark buys a scarf, 2 badges and a whistle from a sports shop. How much change does he receive from £20? Classic old SATs question, this one. So let's see what we have. So my first thing is, everything's in 99. So what I'm going to do is I'm going to round everything up. So we've got £4 here, because this is basically £4. This is £6. This is £2. This is £1. And this is £3. So I'm going to think of it in terms of the whole numbers. It'll make my life easier. So he buys a scarf, so that's 4, plus 2 badges, so plus 1, and a whistle. He buys that for 2. So that adds up to 4, 6, 7, 8. Okay. And we'll work out the change he receives. So whenever you say this change received question, essentially they take the answer that you just did, and you take it away from how much you paid for it. So 20 minus 8 is equal to 12. We've still got some answers that are quite close to 12, so we have to be careful. So what assumption did I make here? Well, I rounded this up by 1 pence. I rounded all these up by 1 pence. So when I've got my answer, it's got an extra 4 pence that I shouldn't have included because I've got 4 items. So I need to... so I've got an extra 4 pence here. So what I need to do at this point is make sure that it matches correctly. So I need to add an extra 4 pence on here, because I added it at the start. So then I get £12 and 4 pence. So even though I rounded, I need to make sure I include that at the end. So that gives me answer A, like so. Question 24, Winston's packing eggs into egg boxes. He puts 6 eggs into each box. How many complete egg boxes can he fill? And complete is an important word here. Can he fill with 106 eggs? And as soon as you've got each as well, you're thinking dividing. Again, things are indicating on dividing. You want to see how many boxes fit into 106 eggs. So the calculation we need to do at this point is 106 divided by 6. Want to see how many lots of 6 fit into 106. Again, we've got a classic division question here. So 6 into 1 goes 0, carry the 1. 6s into 10 go 1, remainder of 4. How many 6s into 46? Oh, that's a bit tricky. Again, I use my times tables. I know 6 times 6 is 36. 7 times 6 is equal to 42. 8 times 6 is equal to 48. Oh, that's too much. That doesn't work. So then we get 6 goes into 46, well, 7 times. And what's the difference between 46 and 42? Well, that's 4, so remainder 4. But we only need to know how many complete egg boxes, so we want the big number here. So it's just going to be 17 boxes. All good. And our last question. So when this net is folded into a cube, the classic T net for a cube, the opposite faces of the cube add up to 12. What is the missing number? So we need to think what's opposite what. So when you fold this up, try and visualize this. This side will be opposite this side. So I'll color code that in red. This side will be opposite this side. Again, these do add up to 12, so we're kind of checking this as we go. So this mystery side, the one right at the bottom, let's do this in magenta, nice colour, is going to be opposite this side. So these purple need to add up to 12, so 4 plus something is equal to 12. What's the something going to be? I think we can all see that's going to be 8, because 4 plus 8 is equal to 12. Okay, so you can check your working. Again, this comes from the mark scheme. So notice it did a similar way of 23, the way I did this as well. Round everything, change it by 4 at the end, and then a little bit of bus stop division, and then a bit of work with nets. Okay, Hope you've liked this video. Again, please give a like and subscribe if you want to see more 11 plus videos. It's been interesting trying a bit of year 6, year 7 maths compared to doing the IB. So it's a nice change. And of course, the real thing is in September, so make sure that you are ready for it. All right, see you on the next video. Bye-bye for now.